Okay, we'll start our lecture. But for the homework the homework 3 we can postpone 1 week because I just finished part of the stereo, so I will teach you more about stereo again. So for the homework 3, 4, 5, okay. Originally today we will turn in the homework 1, 2, 3, but I think homework 3 I will teach you more again. No, not again, more. So you will turn in the homework 3, 4, 5 next week, and I will explain the homework 3, 4, 5 again. Okay. So we continue our lecture about stereo. So for the stereo, the important thing is try to, first of all, for the first we call reference image or left image, and the right side image. And how can we find the corresponding point? That's a stereo. Okay. So first of all, how can we find this one? This line and corresponding line. And actually, this is called epipolar line. So we can use epipole. Or if the two images, they already align well, and then that's meaning this epipolar line will cross to the other epipolar line. So any point along the one epipolar line, and then you'll find a corresponding point, and this corresponding point should appear or should locate at the same epipolar line. So we can see this one. So in left side, the corresponding point to here, the position, and you will search in the right side image, you will search from right to left. However, the search region or search range, you should give him on the search range. At this point, if you come here, you'll find the corresponding point should be at your left-hand side. And then, what's the search range? You should define the search range. If the search range is longer, it will take time. So search range usually will be related to the baseline. That's meaning if two images, the baseline is large, that's meaning your search range will be large. So usually we will give you the information about baseline. And also we will give you what's the search range. So search range sometimes it's like a 16 pixel, 32 pixel, or 64 pixel. But what I mean is meaning from the course this point, and you search 64 pixel. And based on the search 64 pixel or 32 pixels, and you try to find, use the SAD, I will tell you about that one later, and try to find the minimum value along this 64 pixel, and that's your corresponding point. And between two corresponding points, the distance between two corresponding points, that's what we call disparity. The difference between two pixels, distance between two pixels, we call disparity. Okay. So you have what you do. First one, you should based on the epipole and try to find corresponding epipolar line. Or you can do alignment, and suppose it align, or like your homework, they already align well, and then just based on the same the same line. So this position is suppose this is 100. Suppose this 10, and x is 100 and y is 10. So this will be 10. And your 100 will be here, and this point should be less than 100. because this point should be your left hand side. So like this one. So suppose this 100, x-axis is 100. So you compare here. So this corresponding point was less than 100. Suppose this is a 150, and you come here, and your this corresponding point will be located at your left-hand side. How do you find the corresponding point? Basically, based on this point, we'll pick up like a 3x3 window, and you start to search, and then try to use SAD sum absolute difference. So if a 3x3 is nine elements, so each position, you just subtract point by point, and along this one. So suppose your search region, search line, actually is 1D search. Search line, suppose 64 pixels. That's what we need to give you. The search range we need to give you. So it's 64 or 32, sometimes 50 something. We give you, and you just pixel by pixel try to do SAD and try to find the minimum SAD, and that value will be your corresponding point. However, those kind of process in the book, they don't tell you. No book talk about this one. They just tell you you will try to find corresponding point, use SAD. Okay, so I explained to you the search region, but it's not 2D search region, it's 1D, because you already find a corresponding line, what we call epipolar line. Okay. The other thing is suppose, because sometimes it's important, there is no corresponding point, because we call partial occlusion. That's meaning in one camera you can see the point in position. In the other camera you cannot see the point because occluded. We call half. I will tell you about this one later. Half occluded. In stereo, many situations have a half occluded. In that situation, you don't know. So, but you can find, if your SAD value, you have used two ways to find the half occluded information. One way is that if your SAD value is high, suppose you search 64 pixels, each of the SAD value is higher than some threshold. That's meaning you did not find a corresponding point. That's meaning you don't have a corresponding point. The second one we call left-right checking. We'll talk about, let's explain this one later. Left and right checking. That's meaning it's important for stereo. That's meaning first time you use a left image to be your reference, and you try to find a corresponding point in the right hand side. Because you find a corresponding point, but if your threshold is higher, usually we will define that corresponding point to be value 0. That means you don't have a corresponding point. And the distance between two corresponding points we call disparity. Okay, we just talk about disparity. So disparity is distance, how many pixels between two corresponding points. However, if you cannot find corresponding point, we will assign the disparity to be 0. 0 meaning it's background. It's meaning the value is not disparity. And that's meaning that that's your background. That's meaning the background is infinity. The infinity. So it becomes black. And the other way to check whether there exists corresponding point, we call left and right. Left and right check is meaning in left hand image it will be your reference, and you check your corresponding point in the right image, and then do again in the right image. You try to find the same position, but your search region will be in your right-hand side, and try to calculate your disparity. So you become a two disparity map. And if the two disparity map for each point, if it's not consistent, then exists like a 2 pixel difference. That's meaning it's half occluded. And then you delete this point, become 0. That's meaning this point has no corresponding point. Okay. And well, I will explain this one later. So here, so far we talk about is that, first of all, we explain to you what's if you find a disparity value for each pixel is D, right? And we give you the best line, and we give you the focal length, and you can find the distance from the camera to the object, or from object to the camera. So you can find the Z, the distance. So disparity is not a distance. Disparity we call parallax, 视差 parallax. So if disparity large, it's meaning the object close to you, right? If the object close to you, and the disparity will be large. Disparity is far away from you, be small. Okay, so based on the disparity, you can find the depth, Z distance. And page 25, this is this one. So this is 2 points. So the distance between 2 points we call disparity. So next step we will try to tell you is that, and this is try to find corresponding points. But usually the window is 3 by 3. 5 by 5 is too big. 3 by 3 because each pixel you need to try to calculate to find a disparity. And then it takes time for each pixel. So 3 by 3 is good enough. Okay. So here, what's the purpose for epipole? Epipole is try to, I think in this page, right? Yeah. Epipole is try to do is you have an original. Usually we do template matching. Template matching is 2D search. You do search is from top, left top to right bottom. But let's talk, that could take time. So we use a 1D search. So we will just want to search along the epipolar line. So here we try to teach you what's epipolar line. Okay. So last time we talked about this one. So any point in the world coordinate, we transfer to the camera coordinate. So right now PL is the 3D point in camera 1. P right is a 3D position of this point in camera right. Okay, so any point they project on the left side image. This is one point and the other point. And here we want to teach you what's epipole. Epipole is the same. This is a camera 1 or camera left, and you'll find the center, actually the middle of the center of the right-hand side camera. They project from here. You can see this camera, and this point we call epipole in the left-hand side. The same in right-hand side camera. You can see your left-hand side camera, and you can see from here project to the left and right side camera is called epipole. So any point 2D, this image, you can connect this point to the epipole with this called epipolar line. So the P left will locate on epipolar line left. We will find the corresponding epipolar line here, and your corresponding point will appear at the epipolar line right hand side. If so, any point here, the same. You will any points here, okay? Your epipolar line will pass through this epipole and your epipolar line. So that's epipolar line. So epipolar or epipolar line will reduce your search region from 2D to 1D. Okay. So how can we find epipole? But before we find epipole, this epipole. I will tell you there are 3 situations for the two camera, the position for 2 camera, the 3 situations. The first situation is in page 36, is a 2 camera. It's not parallel. There was some angle. So 2 camera is like this way. So you can see, we all want to see the front of me as 2 camera here. So this first situation. The second situation is suppose one camera is parallel to you. This way. Actually, this way is like this one. If you come here and you can see this one. So what you see is this will be your reference camera, and you see front of you, the view, and the other camera will be side of you. So it's second situation. So second situation is this one. And the third situation, actually we prefer this one. It's 2 cameras are parallel to each other. If 2 cameras parallel each other, that's meaning, I will go back to here. So any epipolar line, they will go through the epipole. Any epipolar line will go through the epipole. However, when you do the parallel, that's meaning any epipolar line will parallel to each other, and the epipole will be located at the infinity. 当你2个那个镜头平行在一起的时候，因为你这些 epipole 都是平行的，因为所有的 epipole 的线都会交集在 epipole 上面一点，所以它的 epipole 变成在无穷远的地方这样子。这种状况是你的 epipole 会 locate 在无穷远。So this one is meaning all the epipolar line will parallel. So this one will be this one. So this epipolar line will parallel to the other one. So all the epipolar line will parallel to each other. And this line will cross into will be crossed over to be the other image. So with the same epipolar line. So we prefer this one because this one will be easy. Okay. So most of stereo include a real sense. Okay. Most of the stereo cameras, they will parallel to each other. That's meaning you are easy to find the corresponding epipolar line. So here we go back to the epipolar. Okay, and epipolar. What I try to teach you is how can we find the epipolar line? This line, and how can we find the corresponding epipolar line here? So here we would like to introduce 2 important terms. One called essential matrix, the other called fundamental matrix. Okay. And in OpenCV, they talk a good job about here. OpenCV, they talk about stereo, and they also talk about essential matrix and fundamental matrix. And then also they give you the source code, and they'll automatically help you to find epipolar line. So in mathematics is this way. Okay. So capital P is a 3D. A is the intrinsic parameters. Suppose you already know by camera calibration. So each camera has its own intrinsic parameters by camera calibration. So you know the A right. So 3DP, this one, P in 3D, you project on the 2D, become this 2D point and the 3D points. Okay, and A is the intrinsic parameters. So for the projection. The same in the right hand side, you have a capital P 3D project to the 2D, this one. And the relationship between two camera, the same point, is P, the same point. So P left and P right in two camera coordinate. Okay, original P is the world coordinate, and world coordinate like a calibration board is only one position. However, you have two camera, so two camera has different position. So this the world coordinate, the point. If you transfer to camera left, will become P left. Transfer to the camera right will be P right. And this 2 point, the relationship between these 2 points will actually be the same as the relationship between left side camera and right side camera. So will include rotation and translation. 3D to 3D, the information is rotation and translation. That's meaning in this side, the left camera is meaning the two camera position. So there you have a translation between two camera. So the translation actually is equal to the baseline. The translation information is the same as baseline between two camera. So this is baseline. The rotation you can calibrate because two camera you can do the same chessboard. The same chessboard based on two camera, the chessboard you can rotate, and you will find the relationship between two camera。就是说，在两只摄影机你怎么摆，你只要跟一样，你只要一个摄影机在前面，不，一个那个 chessboard， 就我们上面前面讲的 chessboard 放在前面，那你同时两只摄影机去看它的时候，那你就会找到每只摄影机的内部参数，你也会找到这个每只摄影机跟 chessboard 之间的 rotation 跟 translation。那这样的话，你每只摄影机跟 chessboard 就有了 rotation 跟 translation。那这样的话，这样你的两只摄影机之间的关系的 translation 就是你 baseline， 这是你可以设定的。那 rotation 就是两个 R 相乘，就是你这个摄影机跟 chessboard 之间有的存在一个 R， 那右边摄影机跟 chessboard 存在 R， 这两个 R 相乘就是你的两颗摄影机之间的 rotation。So the relationship between two camera about rotation matrix is a relationship from left side camera after you do calibration, and you have rotation here. And you also have the other rotation here. So you times two rotation together. So it will become the relationship between two camera. So time two rotation together, become this rotation. There's a relationship between two camera. Okay. So our purpose, the first purpose is we call essential matrix. What's essential matrix? Essential matrix, I tell you the result first. It's E. What's E? E is the meaning you'll find in right-hand side camera, you see the same point in 3D. And after this one, 3D position times essential matrix, this is a 3 by 3 matrix, times corresponding point in 3D in left-hand side camera, they will be equal to 0. That's meaning if you can find the essential matrix rotation and translation between two camera, and then any point in the right-hand side camera 3D, after you times rotation translation, and you can find corresponding 3D points, this one, and the result will be 0。就这个式子可以让你找出，因为你 essential matrix 就是你的这两个 RT 找到了，所以你already know RT essential matrix RT。Given any point in 3D right hand side, you can find corresponding point in the left hand side. Okay, this is called essential matrix. However, we don't have a 3D information. We only have a 2D information, 2D image, because you can see it's from 2D. So that's why we have a fundamental matrix. Fundamental matrix is this one. It's meaning the same. In a 2D right-hand side camera image, the point here, U times fundamental matrix. This is also 3 by 3. And you'll find corresponding point in the left-hand side image, because the time altogether will become 0. 就是说，你在做 essential matrix 的时候，一直 3D 跟 3D， 可是让你 3D 上不知道。那你经过这个的话，实际上可以找到 corresponding point。那既然 3D 不知道，那我就用 2D。那待会会提到这怎么做。那如果 2D 有这个叫fundamental matrix， 就是说，假设你 F 找到了，那 F 是什么 ？F 就是你从右边摄影机 reproject 到 3D， 因为这个 A 就是原来的 P 嘛，你 reproject 回去，然后经过 rotation translation， 然后再 projection 回来，那这样的话，你就可以找到你 corresponding point。那这个称为fundamental matrix。So fundamental matrix is meaning any point in the 2D point in the right-hand side after you reproject to 3D, after rotation translation, and then project to the left-hand side image, and you time all together, multiply all together will become 0. That's called fundamental matrix. Okay, so back to here. So how can we prove this essential matrix? That's from here. Okay, because it's based on this one. Based on this one. So there's a P minus T, P left minus T is here. P left minus T. So P left is a vector here, and T is here, and your result will be P right. P left here minus P T. P left minus T will become P right here. This vector. Okay. So P left minus T will become this one. Will become actually this equation. R inverse to PR. So will be here. Okay. So this result will become this one. P crossover P crossover YG crossover T. That's meaning here. T, right? Crossover P will be your vertical direction. 你的 T 啊，跟 PLYG， 那就是你的垂直，这个 C 的垂直方向，这样子，所以就是这个变成这个就是垂直方向。好 ，and this is cross product YG. Any cross product can transfer to inner product. 任何 YG 都会用内积的形式来表示。So any cross product T times P will be Jacobian, this one. So this inner product. And this 3 by 3 and 3 by 1, so they become, this 3 by 3. Okay. And this 3 by 1, so this will be 3 by 1. And this one, this one with this one, both two, they have a 90 degree, it's orthogonal. 就这个跟这个是垂直90度，所以 the inner product will become 0。就这个跟它的法向量 the normal direction of this one, actually no, the same normal direction this one, also normal direction this one will become 90 degree. So this result will be 0. Okay, so we continue. So finally, we'll find the P R times Jacobian T and P left becomes 0. And we define the R and the T. This is inner product. This is called essential matrix. So essential matrix will include rotation and translation in 3D. 可以哈 ，OK， 所以这个是变成这里变成1乘3 1 by 3 3 by 3 3 by here 3 by 3 and 3 by 1, so become 0. So this is called essential matrix. So what's the fundamental matrix? We start from here. We start from here. Because right now we want to do 2D, because what you see is 2D image. So this 3D actually is a 3D, meaning 2D reproject to, based on the intrinsic parameter, reproject to a 3D. So we'll P right. The same, the left-hand side is a 2D, the point on 2D reproject based on the intrinsic parameters will become 3D. So they'll become this one. And we will transfer. So the A will become just a switch. So switch to this one, switch to this one. So the A is the intrinsic parameters. So this A, E, A, this one will become, we call fundamental matrix. Okay. So how can we explain this one? It's meaning in the right-hand side 2D, any point, image point in the right-hand side, after they project to the 3D, after rotation, translation, and then we project to the left-hand side camera, and this will match the corresponding point. And this equation will become 0. So in our any case, based on the camera calibration, we will find the rotation translation between two camera. We will find intrinsic parameters for each camera. So we know F. So F is a 3 by 3 matrix. So that's meaning if we given any right-hand side image point, you can find the left-hand side image point. Okay, so this is called fundamental matrix. But actually, it's not easy. It's not easy. So for this is a theory. 这理论上是这样。理论上就是说 in theory, if you already know F, any P, you can find a P corresponding point on P left. This is theory. But in reality, you cannot find exactly the point. So what we will do is based on this one. I don't explain others because this is how to find epipolar line. It's a bit complicated. But OpenCV already write this equation for you. So you can just call OpenCV. OpenCV, they will find corresponding point. That's meaning if you given you any P, they can find corresponding point 9 for you. So the same in theory is this one, but in reality, you cannot find this one. So what you can do is basically you will use OpenCV and try to find corresponding 9. So that's meaning you'll find this one. OpenCV will help you to find any point, any 9, they'll help you to find corresponding point 9. Okay, so first of all, you use OpenCV to find corresponding epipolar line, the corresponding line. And then you still need to do the search. So still need to do the search. Okay, that's in practical things. So we skip. we go to page 48. Page 48. This one. So here is mean try to tell you is suppose they have two camera in the environment, and so any two image you want to do is to be parallel, and this kind of process we call rectification. We call rectification. So for the multiple camera, we have two kind of process. One called camera calibration, to calibrate intrinsic parameters, extrinsic parameters for each camera. The second one is that based on the camera calibration, we will do that we call image rectification. But in Chinese, we always talk about both is the same. We call 校正哈，这两个我们都叫校正，但是在英语上是不一样的啊。In English, one is a calibration, the other is rectification. What's a rectification? It's meaning any camera you want to find corresponding point. So you will, based on the rotation, you will try to let two virtual images to be parallel to each other. 就是说你这两个角度不一样嘛，那你事实上在做 you want to find corresponding point， 你事实上要让它做变成平行，就第三种摄影机的状况。那这样的话，事实上就是这里转这个OpenCV also tell you about this one, but they don't tell you very clearly. Okay, so that's meaning you will rotate half of a rotation, half rotation here. 所以你本来也摄影机是这样子，你要把它经过 rotation 把它变成 virtual 的平行这样子。And if you virtual parallel, you can find corresponding line, corresponding point. So that's it for the process of try to let the two camera to be parallel to each other. And right now, we will try to find corresponding point. You already have an epipolar line. Actually, because if you do this one, you'll find all the image will become this way. This way. 你在空间中两只摄影机不用摆平行，但是你经过刚刚这些校正完以后 ，after you do in the reality, sometimes suppose this room, and I have a 20 camera here surround this room. I can do the 3D the view here. Okay, but I have multiple camera, and each one between. So I have one reference camera, and each camera will corresponding to a reference camera. 就我一定要找一个当 reference 摄影机。我有20只摄影机在这里哦，我是要把一只当 reference 摄影机，加第一只当 reference 摄影机。那我要做的是第二只对第一只，第三只对第一只，第四只对第一只，是这样做，不是1对2、2对3、3对4，不是，是你要以 reference 这一只为主。这是一个概念，说 20 image 20 camera only one reference. So the purpose is suppose first camera will be your reference, and then the second will be 2, 1. Third camera will be 2, 1. Fourth will be 2, 1. However, sometimes it's not easy. So what you can do, you will do 2 to 1, 3 to 2, and 2 to 1, because between two camera, it will rotation translation, right, after calibration. So 2 to 1 have a rotation translation. 3 to 2 have a rotation translation. Okay, 4 to 3 have a rotation translation. And then the relationship from 4 to 1 will become 4 to 3 and do the multiply rotation translation. So 4 to 3, 3 to 2, 2 to 1, so become 4 to 1 this way. 就是说我们通常是只有一个 reference 摄影机会比较准。那个 satellite image 的 set, one will be your major coordinate. Okay, so what you do is 4 to 3, 3 to 2, 2 to 1, and then from 4 you can directly transfer to 1， 是这样子，是要这样去做。所以 stereo the algorithm is easy, but when you multiple camera, you a little bit complicated this way. 那所以我们刚刚有讲到这些东西以后，我们现在要做的就是怎么找啊。So all the multiple camera, 220 camera, based on calibration, based on the rectification. Remember, have a rectification, and you have all relationship between all cameras. And so you're ready. And after you're ready, this one, the next step, we'll try to find corresponding points. So after you find a corresponding point, and you can have a disparity. After you have a disparity, you will know the depth between you. But one more point, okay? The disparity sometimes what I say is 4 to 1, right? 4 to 1. But sometimes we don't do that because if this the image the camera is far away from you, sometimes you don't have the same scene. Because the first camera can see this way, and the 20 camera probably see the other way, but they don't have a corresponding point. So it depends. So sometimes it's only one reference camera, and then each camera will have a disparity between 2 to 1, 3 to 1, 4 to 1. But in the other situation, because we don't have the same view between different cameras, so sometimes the disparity is 2 to 1, 3 to 2 disparity, 4 to 3. So individual disparity. So that depends your situation. Okay. So we take a break and we'll continue to talk about stereo.
你说的那个评论，他是在做那个桌球计算数分析。
有什么？
那个你说那个有个评委，对我还不错。他好像
什么评委？
就是那个国班的申请的评委。
哦，
就是有一个老师有寄信给我。
蓝坤仔啊。
他说他在做桌球计算数开发系统。
他不是这个方面专长的，他做很杂。
及桌球运动科学。
不止，因为我算资深的，认识一些人，所以我大概跟他们打个招呼了。
他做国科会精准科学计划，就是
他是另外 group 的。
跟你不一样了，跟你不同团队。
他是做那个中医什么针灸什么的。蓝老师啊，蓝坤仔。
对，他说他也有做，就是
他不是那边专长，他不是 region 的。他做很杂。
然后你也是也是精准运动计划，就是所以
不一样啊。
他跟你是分别两个计划。
我们不止两个。
我以为是同一个。
他是第一期的。他第一期 我们是做第2期，第1期结束了。
哦，可是他说是明年1月才开始。
啊？对啊，明年1月才第2期啊。他现在不知道跟谁在一起，我不晓得，因为我们这边有3个团队，以我这边为主，没有他。男老师，但是我们可以看蓝光展览，他不是做这面的，但他做很杂，他做一下子做那个什么，就针灸啊，他是做针灸中医。
我看他是做什么，有
做很杂，
智慧医疗之类的，
就很杂，对啊，就针灸，他跟那个叫什么？中国医药学院那边做啊，因为他是那边是读一个硕士这样，他做东西什么都做，对，有点乱，不要这样乱，但就 focus 在，也不用跟他，因为我们比他还强，他专长不在这里了，所以不需要跟他们，我们会跟我们这边16个老师，这边团队很大，还有跟那个叫什么体健修所，就你原来那边呢、因为你们的教练都是体健修所的、
就是那个
我可能会变中心主任。
中心，
他们成立一个智慧运动中心，
因为我弟弟在中心读，
不中心的 center， 中心我们要成立一个 smart sports center，对，你弟在中心的，
中心读书有一个老师也是在做桌球，
现在不少人做桌球，之前他们第1期就是遇到问题，那个叫谁就你们心理系那个啦，我学弟啊，那个叫谁，肖夫人啊，他们就做不出来嘛，跑来找我啊，我没时间嘛，对啊，他们就有弄出个弄得还不错肖夫人现在变在我团队里了，
因为我之前
他们现在做网球，他们现在第2期要做网球，
因为之前我在他的实验室就是做桌球，然后我就是做桌球发球判断，然后量测脑波，我觉得真的蛮困难，因为要从他的判断跟他的脑波做关联，我觉得很难。
我们做
就是会做不
我比较务实的，
可能做硬体的东西会比较容易一点，
叫怎样？
比较容易
做硬体，
就是
我们不做硬体啊，
就是实际做一个东西，会比从脑波判断还要。
我们做软体啦，我们
嗯，
做硬体，但是我们是买设备来，简单设备，我们做硬体。
就是
有就我们如果要硬体就跟人家合作嘛，所以我们跟很多人合作。
就是比如说做一个实际的东西，可以用的东西，就感觉比